Hey, this is Step Amit. Welcome to my Exorcism.io series. In this video, I'll be working through the wordy exercise from the Exorcism.io Ruby track. So in the wordy exercise, we need to parse and evaluate simple math word problems, returning the answer as an integer. So let's look at an example here. We need to be able to add two numbers together from the string, what is 5 plus 13? And that, of course, evaluates to 18. We need to be able to handle large numbers and negative numbers. So that's the first iteration. Then we'll need to add subtraction, multiplication, and division. And then we need to be able to handle multiple sequential operations. 5 plus 13 plus 6. 3 plus 2 multiplied by 3. So notice that we're just processing them left to right. 3 plus 2 is 5, multiplied by 3 is 15. So not 3 times 2 plus 6. We're not respecting the order of operations of multiply before add. We're just gonna process them left to right. That makes it easier. And then as a bonus, if you'd like, handle exponentials. What is 2 raised to the 5th power? Okay, so let me go ahead and grab this and pull it down. Wordy. Start a new TMX session. I'm going to copy in this rake file, which allows me to run my tests by simply typing rake. And I have that hooked up to a Vim keyboard shortcut. Right now it's F8. So let me go ahead and get rid of the empty RB file that just has comments in it and check out the test. All right, so what do we have here? We've got a class named word problem that lives in a file called wordy.rb. We initialize it with our word problem, and then we call the instance method answer, which will return our integer. Okay, that's enough to get going. Let me open up my testing pane here and run the test, which of course will fail because I deleted that file. So let me recreate it as an empty file here, switch my panes, and try again. Now it's going to fail because I need to initialize the class. So let's do that, word problem. And of course, now to fail because we don't have an initialize method that accepts an argument. So I need to do that. And I'm going to go ahead for the moment and set up an adder reader to hold this word problem, and then initialize to take word problem and set the instance variable. Now it's going to complain that we don't have an instance method answer. Yes, undefined method answer. So let's create that. And this first version just has to return 2. And that'll be enough to make this first test pass with a hard-coded answer. So we're just going to let the test guide us as we go. And so that's why I hard-coded the response. But this second test is going to make us actually implement some type of, some version of this because this expects a different response. This expects 55. 53 plus 2 should return 55, but we're going to return 2, so this test will fail. Okay, so let me take a step back and think about this. We need to be able to parse this string into component parts, and we need to process them in order. We're going to have some tokens here that don't mean anything. We know what they are. They're the beginning of the question, but we don't do anything special when we see them. So we have some group of tokens that we're going to ignore. We have some that are integers, and then we want to operate on those integers. And then we have some tokens that represent an operation, something to do. In this case, plus. And so we want to have a handle on this first integer, and then we want to call this operation on that integer, giving it this following integer. That's sort of the thing that we want to be able to do here. For these first two examples, I think it'll be fairly straightforward. Hang on, let's think about this. All right, so what I really want to do here is, I was using the word token here, is I think I want to go ahead and I want to tokenize this as if I were, I want to, and by tokenize it, I mean I want to split it into individual words. And I don't think I'm going to need to reference the whole word problem. So I'm going to back up. I'm going to change what I did here. Instead of word problem, I'm going to call this tokens, and it'll be an array of the words. So word problem, I'm just going to split it. And I need to take my tokens, and because I'm processing them and I'm processing through them, and I'm going to spit out a single answer at the end. That is the result of processing them. Anytime I have an array of things and I need to process them in some way that results in a single answer, I think of reduce. That's a reduce operation. I'm reducing my list to a single answer. So I'm going to try this. And so reduce, you initialize with a starting value, a starting accumulator or result. In this case, we're starting out at 0 because there's nothing, there's no value at the very beginning. And what I'm going to do, let's see, I'm going to use the block version here. I have my result. So the first thing, you have two things in a reduce. You're given the result, which is whatever the last block returned, or starting at was 0, and the token. And so what I need to do is I need to look at the token and determine what to do with it. In any case, I have to return something from this block. And whatever I return will be the result given to the next iteration, the next token. So I know that my first two. So let's think about this. Let me think about this. For now, I'm only going to deal with plus. And so I think what I'm going to do is, if my token is an integer, I'm simply going to add it to the result and return that. And that's where I'm going to start. So this is a situation in which I think a case clause is what I need, is what I want to do. I hate them. I think they're usually code smells, but this is an instance where I think it's what I want. And so I'm going to match my token against a regular expression. And so what I want to know, case token, when I have a digit. So the regular expression for that is going to be, let's see, minus 0 or 1 minus. Well, let's not worry about that. Yeah, I don't have any minuses yet. I just have a regular digit. So what I need is 1 or more digits. When I have this will be and I need to match on this, right? No, I don't need to match. I don't need to match anything. So I've got a token. I know it's a digit. And so what I want to return for the next result is result plus token to I. And that, I think, will be enough. No, what happened? Undefined undefined plus method for nil class. All right, so let's see here. Oh, because I need to handle the else case, the default case will just return result. Whatever I had before, that's what I need to return. Okay. All right, so for the moment, so let me explain again what's happening here. So tokens in our first example is an array containing what is 1 plus 1. So when the token is what, that very first one, result is 0 because I'm passing in 0. I'm initializing with 0. And the first token will be the word what. So when I enter my case statement here, this will not match. It'll fall through to else. So I'm just going to pass 0 on to the next token. So is, the same thing will happen. It won't match on digit, will fall down to else and return 0. The next token is 1. That will match on this regular expression. So I will add 0 plus token.2i, so 1 as an integer. And that's what I'll return. So this is now 1. So the next token is the word plus. So result is 0, token is plus. It's going to fall through to result and just return 1. The next token is 1, result is 1. 1 plus 1 is 2, and that's what's going to return from the entire reduce statement. And that's what's going to be returned from the answer method. All right, so this is going to work until the next one here. Now I have to deal with negatives. I'm not dealing with negatives. So I think I need to be more explicit here, because my match statement is it's matching that there is a digit within that token, that there is at least one digit. So if there was some word that had a number in the middle of it, I don't want to do the math on it. So let me be more explicit here. So I want the whole thing from beginning to end, that word to be a digit. Now it'll fail because of the minus, the minus sign. All right. So what I want to do here is allow 0 or 1 minus signs. Okay, no. I broke it. What's going on? Everybody's failing now. All right. So here's the problem. This question mark at the end. We're matching on that. So what I want to do, I think I want to allow it because the 2i will strip it. So I think I'm just going to allow it. Okay. Another failure here. Oh, I'm requiring it. So there needs to be now. Oh yeah, I need another question mark there because I want there are 0 or 1. There we go. Okay. Yeah, that was a little more complicated than I thought it needed to be. I mean, I what I can do is I could go back to the simpler version and just make sure there's at least a digit, and then I'm just going to parse whatever that digit is. But this is a little more explicit, so I like it. I think I'll keep it like this for now. Okay, so this I think is going to get us through until we have to deal with minus here. Okay, minus. So now's the first case where we have to deal with a different operation. And I think what we can do is handle it the same way. But this will have to operate a little differently. Let me comment this one out so we can see it. So we can pass this operation. We're going to have to determine it based on the word, based on the token. So I'll just show you that what we can do. This is really syntactic sugar in Ruby for this result.send with a method name and the arguments to that method. Let's show you this will work. The method name is a symbol. I think it can be a string as well. Yep. And so what I can do is, just to show you here, I can set that. Let me call that operation. And I'm going to set it to a plus sign there, to the plus operation. And what I can do is turn this result that I'm passing around. I can just pass an array around. And so I'm gonna start with the initial integer, and then I'm just gonna start with the addition operation, because when we get the very, very first one, hang on, I'm gonna change this to accumulator, or cum for accumulator. And I'm going to get those out of it. So now I'll have resultant operation. And then at the end of this, I'm going to need to return first, because I just want the integer, whatever the integer value is. And now what I need to return here is result in operation, whatever the current values are. Results. Let me now put parentheses around this, an operation, whatever it is. And I need to determine the operation based on the word. All right, so now that code works, but it's going to fail now because we're always adding, and we need to subtract when the word is minus. The token is minus. So I'm going to need to, okay, let's think about this. What happens here in this case? My accumulator has 0 for the result and plus sign as the operation when I begin. And that's what gets passed in when the token is what. That's going to fall through to the else block. And so that accumulator with the 0 and the plus sign is just going to pass right through. The next token is, same thing. We're going to hit the else block. The original resultant operation are going to get passed right on through. Then we're going to hit this number 4. This token that is the number 4. That's going to match on the digit block, which will add 4. It'll use the operation, which is currently plus, to add 4 to 0 and set that as the new result. And it's going to pass the current operation, which is still the addition operation, and return that as our new accumulator. The next token, we hit that, and our accumulator looks like 4 with plus. Well, what we need to do is we need to now recognize this. We need to recognize this word as a keyword, as an operation word, and we need to do the right thing. We need to set the operation to the minus sign, the negative sign, as a symbol, so that when we get to this next integer, it will not add, it will subtract. So I need a new case here. Sorry, that was a long explanation for what needs to happen here. Again, I'm going to start at the beginning of the string, and I need a word boundary because I want it to be a whole word. And I have 2 words here. I have plus or minus. When those match, I need to do something. I need to look the token up and translate it into a symbol. Well, that tells me right away that I want to store that in a hash. It's a dictionary, right? So I'm going to assume I have a hash as a constant called operations, and I simply want to look up my token. That's my operation. And so I want to return result and operations. So what does operations look like right now? I've got 2 operations at the moment. Let's see, minus, which gives me the symbol minus, and plus, which gives me the symbol plus. All right, does that work as is? Have I done enough here? Yes. Okay, so I'm going to keep going here. Multiplication, of course, this will fail. I haven't done that yet. Multiplied by. Because I'm dealing with the token at a time, I'm going to key on the word multiplied. That's going to be my key, and I'm going to ignore by. So that failed because I'm not doing multiplication. Let me add multiplied here, and then I need to add it up here. All right, and so next will be division. Same thing. It's going to fail for now. So let's add divided. And again, I'll ignore by. Test multiple additions. I think this is just going to work. All these multiples should just work. Subtraction, then addition, that should just work. Multiple multiplication should just work. Addition and multiplication. You should ignore order of precedence. Okay, that just works because we're just processing left to right, I think is what they wanted us to do there. Multiple divisions should just work. Unknown operation. This needs to raise an argument error. This will fail because we're not raising any argument error. And I think we'll probably return 52. Well, it doesn't matter what we return. We need to return an unknown operation. Okay, so in order to do this, I think what we need is a list, an explicit list of known ignorable terms. And if we come across any term that is not in our known ignorable term list, we will raise an argument error. So else, this is really going to become a when, matching something. And then else will raise an argument exception, argument error. Argument error. So what does this list need to be? Well, it's got to be a list of words that we know. So what, or again, we want this to be, oh yeah, didn't do that. We want this to be the entire token to match. So let me add these. What is a known token. By is a known token. I think that's it. Yep. What is by? Non-math question. Who is the president of the United States? So this should raise argument error. Because it contains tokens that we don't know. All right, that was it. That's all of our tests. So let me do a little bit of refactoring here. And really, I think the only thing that I want to do is I want to take these regular expressions and name them. So just to be a little more explicit here. So I'm looking at my token. When it's a digit, I want to do that. Yeah, so let's call that digit. In fact, I'm going to put them below. I'm going to put all these below operations, and I'll keep them together. Digit. Operation. Whoops. I'm going to call this ignore. When ignore, I don't know that I like that name. If you got a better name, let me know in the comments. I'm not sure that I really like ignore there. Let's see. It's the token. When digit, we're going to do the math. We're going to perform the operation on our result with our current token as an integer. When it's an operation, we're going to get the new operation. When ignore, we're just going to pass what we had. Otherwise, we don't know what it is. We'll raise an argument error. When ignore, when digit operation. Known keyword. Ignore when ignore. I mean, it tells me to ignore it, but I don't know. I think it bugs me that, this is the pattern for a digit. This is the pattern for an operation. What's an ignore? I think that's the thing, is that there's an inconsistency here in the naming between a digit. I know what a digit is. I know what an operation is. I don't know what an ignore is. I know what to do. It's telling me to ignore it. Keyword, would that be? It's a keyword. When keyword, or when known, or ignorable. All right. Ignorable. I like that. It's a known list of ignorable terms. One other thing I'll mention here is that, see, I have operations up here and I have operation. And so the natural next question to ask is, can or should I eliminate this duplication? What if you don't see the duplication? It's the list of operations here, and it's the keys here in my hash. The keys in my hash and the words here in my operation regex. I could eliminate it. I could take the keys from up here and I could generate this operation, this regex here. The problem with that approach is it's going to sacrifice readability and how explicit this is. This is a situation where I am more comfortable living with a little bit of duplication if it gives me easier to understand, more readable code. Of course, the risk here is that these are going to get out of sync, that somebody's going to add an operation to this list that is not covered in my hash, and there's nothing to return here. But we've got tests, and hopefully they're going to add a test for that, and it'll be apparent right away what the problem is. But yeah, in this case, I'm gonna go with being more explicit in my code. Oh, I just remembered they got a stretch goal for us here. Bonus exponentials. If you'd like, handle exponentials. What is 2 raised to the 5th power? So let me copy this. Let's implement this. The problem is word problem new with our string. What is 2 raised to the 5th power? And I want assert equal, and the result of that is going to be 32. Problem.answer. This is going to fail. It's going to raise an argument error because our app doesn't know the term raised, to, the, or power. There's a bunch of words there that it doesn't know. So to do this, I have a new operation which I will match on the word raised. And I have 3 new ignorable terms, to, the, and power, with a question mark stuck on the end of that token. And then my digit needs to be able to handle an optional th at the end. So let me go ahead and add the operation here. raised. And then my new ignorables, 2 the power question mark. And I cannot put, I'm not going to be able to put my word boundary there, but I think that's probably okay. Because this \b, which marks a word boundary, it's going to be in between these two. And so if I don't need to know that there's a word boundary, because I have the word power followed by a question mark. I just need to know that the question mark follows power. So as far as my digit goes, it doesn't matter if it's before or after this optional question mark because they're not going to be in the same place, but I'll just put it before. I need to check that there is 0 or 1 th, and I put them in the parentheses here because not because I want to capture group, but because I'm checking the entire group to see if it's the entire group is optional. And so raised is a new operation here as well. And that is going to be this. And let me just check this and see if this works. And it does. Cool. And that's it. I don't see any other refactoring that I would do. So let me go ahead and submit this. Hey, thanks for watching. Thanks for sticking through to the end. If you found this video valuable, please click the like button below and subscribe if you would like to be notified when I post new videos. And also, if you'd like a deeper dive into my refactoring workflow, if you want to learn how to write code today that you won't hate in 6 months, maintainable code, and become a superhero to your team and level yourself up more quickly on your journey from junior to senior developer, then you need to check out my tactical refactoring video course linked in the description below. All right, thanks again, and I will see you in the next video.